Toll-like receptor 6 is a key protein in the innate immune system which defends against gram-negative bacteria and some fungi. It resides on the outside of various immune cells, monocytes, dendritic cells, mast cells, eosinophils, and basophils, waiting to recognize a foreign bacterial or fungal invader. If it does, it begins signaling other host cells to activate and destroy the invaders. To go into more detail, TLR6 cannot work on its own and needs to bind with TLR2 to create a heterodimer that recognizes the foreign structures on gram-negative bacteria, lipoteichoic acid, and diacyl or triacyl lipoproteins. These specific proteins are found on the surface membrane of most gram-negative bacteria and are therefore a good way to signal to your immune system that there's an invader. TLR6 and TLR2 are both produced in the Golgi where they bind together, creating their active heterodimer. They are then displayed on the immune cell surface on the lipid raft adjacent to another protein, CXCR4. When this receptor complex recognizes one of the foreign proteins it can bind to, there's a conformational change in the complex, including cluster of differentiation 14 and 36 binding to the complex. This conformational change causes a signal cascade ending in the nucleus, which alerts the immune system to produce the cytokines tumor necrosis factor alpha, interleukin-1 beta, and interferon gamma.
TNF-alpha is a cytokine that stimulates inflammation around the discovered pathogen and then directly activates phagocytic cells. Interleukin-1b also stimulates inflammation. It's secreted to the hypothalamus, which causes fever, and is secreted to the bone marrow to release neutrophils. Interferon gamma release causes the immune system to become hypersensitive to suspect cells, increasing phagocytosis, MHC expression, and other innate defenses. To summarize, the TLR6 and TLR2 complex recognizes many gram-negative bacteria and some fungi by common molecular patterns shared by these pathogens. Once one of the immune cells displaying the TLR complex binds to a pathogen ligand, a signaling cascade begins, which causes inflammation, activates phagocytic cells, and increases microbicidal activity.